My name is Georg Schäfer and I'm a doctoral student at the Max Planck Institute of Geoanthropology in Germany. And together with Brian Holmes, I've developed hidinginplainsight.org, an open access WebGIS project that visualizes how multiple drivers of groundwater stress intersect across Kansas. Our goal is, in a nutshell, to bring all the major forces shaping the state's water future, from agricultural to hydrological, industrial and political drivers, onto one shared map. And on that map you can see that western Kansas is a textbook example of the Anthropocene, the geological epoch in which human systems dominate natural ones. From an Anthropocene perspective, irrigated agriculture doesn't just use water. It reshapes social and natural cycles. For example, in western Kansas, irrigation cools the regional climate, it alters soil chemistry through fertilizer and pesticides, but at the same time, the Kansan agricultural economy and its groundwater is directly linked to national and global food and energy markets. So, what you can see on this map here are layers that usually appear separately. The aquifer level, the GMDs, and how much groundwater they use, but also on a county level, but the analysis goes all the way down to single wells and their use of water over time, but it also includes the associated land use and water use. If you click here on the time slider, it takes you all the way back to 1990. Soon there will be a new application integrated into the website that allows you to draw a polygon anywhere on the High Plains aquifer, or you just take a predefined county, and in a second it shows you the aquifer decline of the selected area since the 1950s, how land use changed since the 1950s, and how irrigation and rainfall interacted during the same time. Soon this will be expanded to also include socioeconomic data like the change in farm sizes, farm income, but also how commodity prices changed since the 1950s. But groundwater decline isn't just a natural or economic issue, it's also a political one. That's why this map also includes political layers like the Groundwater Management Districts. Soon there will also be WCAs or LIMAs. But crucially, the map also contains drivers that are often left out of official maps or which have never been properly mapped, like the aqueduct route, golden triangle of meatpacking, the dairy frontier, ethanol and nitrogen fertilizer infrastructures, and their corporate networks. So, by contextualizing well data with land use and industry patterns, we can historicize the current trajectory of Kansas and in doing so, denormalize it. What now looks inevitable becomes visible as a set of choices, infrastructures and policies that have created path dependencies but can still be changed to a certain degree. By assembling these drivers into a single view, hidinginplainsight.org offers a way to think across disciplines and institutional boundaries. It's a tool to develop a shared diagnosis, a workspace where scientists, planners and communities can explore where Kansas' current trajectory has formed and where it might still be steered. I've used this to communicate my work at universities and high schools, but also for a workshop with a German agricultural state agency interested in learning lessons from Kansas irrigated agriculture. The project is open access and published as a work in progress. Anyone who's interested to use data, contribute new layers, or collaborate on case studies can explore hidinginplainsight.org and help make it a platform or tool that's useful for Kansans and people elsewhere experiencing water stress. Thank you for your time.